Hello everyone, welcome back to the channel Code with AKJ, and today's tutorial of solving Geeks for Geeks problem of the day. And today's problem is maximum difference. So the question says, given an integer array of integers, the task is to find the maximum absolute difference between the nearest left smaller element and the nearest right smaller element of every element in an array ARR. If for any component of the ARR, the nearest smallest element does not exist, then consider it as 0. So the problem here given is to find the maximum absolute difference between the nearest left smaller element and the nearest right smaller element of every element in the array. If a nearest smaller element does not exist, we consider it as 0. So let's break down this example. So the given array is 218. So the left smaller array would be 0, 0, 1, as the left smaller element of 2 would be 0, the left smaller element of 1 would be 0, and the left smaller element of 8 would be 1. In the same way, we consider right smaller array. So the right smaller element of 2 is 1, so we consider it 1. The right smaller element of 1 would be 0, as there is no element smaller than 1, and same goes with 8, so 0, 0. And after finding these two arrays, we need to find the absolute difference. So absolute difference of these values would be 1, 0 and 1. And from this particular array, we need to find the maximum value. So maximum of 1, 0, 1 would be 1. So let's look into the second example. Here the left smaller array and right smaller array would be 0, 2, 4, 4, 4, 7, 2 and 0, 3, 7, 3, 3, 3, 0. We'll find out the absolute difference of these two array values, and finally we'll find the maximum difference, and in this case it would be 4. So the brute force approach of this solution would be to take an array and we'll iterate this array 2 times. We'll have 2 for loops and 2 pointers, and we'll compare these two values and find the nearest smaller element uh, for the left side and for the right side. And in this way we'll create 2 arrays and we'll find the absolute difference between these 2 arrays, and we'll find the maximum value out of those values. So initially we'll take a vector with zeros as initial values, and then we'll fill this particular vector with this absolute difference value. So let's code this brute force approach and let's see if it gets submitted successfully or not. So here's the brute force approach code of this question. Here I've taken the size of the value initially. I've declared 2 vectors, LSA and RSA, and I've called the function left smaller and right smaller by passing the vector ARR. And then I've taken a variable maxi, which is initialized with the highest minimum value. And I've iterated towards the size of the array and calculated the difference of these values. And I have compared this current difference value with the maximum value by taking the max of both. And finally, after completing this for loop, we'll get a maximum value of all the absolute difference. Then finally we'll return this maximum value from the function. Coming to these two functions, left smaller and right smaller, I have taken this vector and initialized with 0 initially, and then I have taken 2 for loops, the one which goes 0 to n and the one which goes from I to 0 backwards, and it finds the minimum value compared to I, and it updates that minimum value to the variable I. In the same way, after finishing all this for loop, the left smaller vector gets updated with the left smaller element for each index I. So the same way the right smaller function works, but as we are moving backwards in the left smaller, we'll move forward in the right smaller element. So in this way, by using 2 for loops, we get left smaller values and right smaller values, and we'll pass these vectors back to these vectors which will store in LSA and RSA, and we'll calculate all the values and we'll return a maximum value. So let's compile and run and check whether it gets submitted successfully or not. It's working for now, so let's submit. So it got submitted successfully, but the time complexity of these two functions would be O of n square, but the expected time complexity is O of n. So we need to optimize the way of calculating these left smaller and right smaller element. So the optimized approach of the solution would be to use stack. Here, let me explain. Here, let us consider a stack here, and generally this stack stores the nearest smallest element, whether it might be right nearest or left nearest. So here, let's take this example to 218, and the approach goes like this. We need to take the value first, and we need to check whether the stack is empty or not. If the stack is empty, then it means there's no element smaller than itself. So we'll consider 0. So initially, since our vector would be 0, so we won't update anything here. And after updating or not updating that particular vector, we'll push that particular current value into the stack. So here 8 goes into the stack. And next, the I moves to 1. And here we'll compare. If the stack is not empty, we'll compare that particular current value with the stack stop value, and we'll pop the stack until or unless we'll get the smallest value, this particular current value. So here the stack contains 8, and we'll compare 8 with 1. Is 8 less than 1? No. So we'll pop this value from the stack. And since the stack is empty, there's no value inside the stack. It means there's no value to its right which is less than 1. So for this case also the value would be 0. So the vector stays 0 itself. So next we'll push this value 1 into the stack, and we'll move I to 2. So here we need to see that since we are iterating from the end of the array, it means we are finding the right nearest element of this array. When we try to find the left nearest values of the array, then we'll iterate from left to right. Since here we are iterating from right to left, we'll generate the values of right nearest smallest element. So coming to the value 2, now again we need to check the values in the stack and pop the values until or unless we'll get the value lesser than 2. So we'll compare with the stack stop value, and we'll check whether the stack stop is less than or equal to the current array element. So it's yes. So since the stack stop is less than or equal to 2, the current array value, we'll update the minimum nearest value with the stack stop element, and finally push that array into the stack. So in this way, after finishing the iteration over the array, we'll calculate and compute all those values of nearest right smaller element. So in this case it would be 1 0 0. So in the same way, we'll find the left nearest value by using stack, by iterating from 0 to n minus 1, that is from left to right, and we'll compute the values, which would be 0 0 1. So after finding these two values, we'll do the same process of calculating absolute difference and finding the maximum values out of those absolute difference values. So this approach would take O of n space, as we are iterating only one time using for loop, and the space complexity would be also O of n, as we are using an extra space of stack. So let's code this approach and see whether it gets submitted successfully or not. So this is the code of optimized approach as we discussed earlier, where we have used external space stack, and we have used a single for loop which runs in O of n time to find the nearest smaller values. So the function goes like this, where we have taken a stack and we have taken a vector and initialized it with 0. So this while loop makes sure that to find the nearest smallest value to its left, and it pops out the elements in the stack until or unless it finds the smallest value compared to the current nums of I. And when it gets that particular value, and we check if that particular stack is not empty, then we'll store the top value of the stack, and if it's empty, we'll remain it as 0. And finally we'll push that particular value into the stack for the next process. And after finishing all this for loop, we'll get a result vector of fully computed nearest values to its left. The same way, we'll compute all those values to its right using the same stack, but here the for loop runs from the end of the array to its left, as we need to compare the values and find the values to its right for each and every current element in the nums array. So after this whole code, we'll get a vector of all those nearest smallest values to its right, and finally of these two functions will return vectors, and it will be stored in LSA and RSA, and finally we'll take a maximum value and compute all those absolute differences, and we'll find the maximum of all those absolute differences and finally return that maximum value. So let's compile and run and check whether it gets submitted successfully or not. So it works for now. Let's submit it. As you can see, this problem is submitted successfully. So in this way, we have reduced the time complexity and space complexity, as they have asked us as expected time complexity should be O of n and space complexity should also be O of n. So I hope you liked my video and my explanation. So if so, please give it a like, share and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.